All right, stats, welcome to a video for you today, the first video of 2023-2024. Hopefully not a lot of them have to come your way because I am with you almost every single day. But Monday, August 14th, the first day of instruction, I cannot be with you. So we're going to start chapter 1 here, which is mostly definitions. It's not bad one to have to use the video to learn from. You guys can read these definitions. I'll explain a little bit of them first first let us go to our sponsors before we get at these notes. We are always brought to you by coffee. Yes, Aldi's finest whole bean coffee right there. Also an Aldi delight here, gluten-free organic brown rice and quinoa pasta. Yes, you have one of the finest Aldis around there in Litchfield. The Bodies and Simple, gluten-free brown rice, pasta. All right. Noon hydration tablets and a goo Roctane plus caffeine. Yummy. And this year, SIU Carbondale is a fine and proud sponsor of Yak Math videos. Folks, statistics is the science, underlying science, a hard science, not a soft science. There is a difference of collecting and organizing, summarizing, and analyzing info to draw conclusions or answer questions. It's about providing a measure of confidence in any conclusions, and that's what we're going to do later this year. An entire group to be studied is the population. Population is the entire group. An individual is a person or object that is a member of that population, and a sample is a subset of the population being studied. A statistic, is a numerical summary of a sample. And descriptive statistics, which we're going to do a ton of in the first semester, consist of organizing and summarizing data. Descriptive stats describe data through numerical summaries, tables, and graphs, which we will do in just, a few minutes graphs, and then mean and standard deviation just in a few short days. In the second semester, we will talk about inferential statistics, which use methods that result from a sample extended to the population. Very important. Then measure the reliability of the result. A parameter is a numerical summary from population. So alliteration, stat, sample, parameter, population. A variable is any characteristic of an individual. A variable can take different values for different individuals. Qualitative or categorical, that's what we'll use this year. Variables allow for classification of individuals based on some attribute or characteristic. We'll see that in a second. Quantitative variables provide numerical measures of individuals. The values of quantitative variable can be added or subtracted, and you can do like meaningful math with them. So there's two different variables here. And we're going to look at quantitative versus categorical. Categorical variable versus a quantitative variable. Which is which? Temperature. All right, those are numbers. I can average them. I can find the difference between them. I can find the middle, the median, the standard deviation in a certain month. Temperature is a quantitative variable. All right, gender. You got male, female. I can't do anything math-wise with that. It's not like male plus female equals 0. I can't add up 2 males and a female, divide by 3, and say, what do I have now? So that's categorical. Number of hours the past month that a college student has studied. Well, I can find the average of that. I can add them up. Obviously, divide and get an average. I can find the standard deviation. I can find the mean. The minimum and the max. I can do all that. That's categorical. Zip code, though those are all numbers. My zip code 62034. Your zip code, I believe, 62056. It's not like I can add those up, divide by 2, and say, oh, the middle of us is wherever the middle of us is on a map. That's not true. I can't subtract our zip codes and be left with a certain zip code that corresponds with a town. That doesn't make sense. I don't do any math with zip codes. All right. And then salaries of employees at a certain bank. Again, I can find quartile 1, quartile 3, the median, the mean. We'll talk about those in a second. All right, more info on variables on the next page, guys. Get excited. All right, stats gets a lot more interesting after the first few days, but we just got to clear up some definitions first. All right, you guys can rate this. A discrete variable, Okay, again, I trust that you can read. So a discrete variable, essentially, it's a countable variable. Okay, so discrete variables means I'm taking on values of 0, 1, 2, 3, and so forth. So there's no decimals. Okay, so just write this down in layman's term, no decimals involved with the discrete variable. Okay. Oh, shoot. So examples of discrete variables would include what? So how about points scored, like in a basketball game? There's no half points. Okay, you can put like goals scored. All right. You can put like SAT scores because there's no decimals. All right, countable, all of that. You can not going to put temperature, not going to put heights because technically decimals can be involved. There's other examples. Okay, continuous variable is a quantitative variable that has an infinite number of possible values that are not countable. And they can take on any possible value between the two values. So what are examples? Technically, height is 1, and we'll look at this later. You're not just 5'10", right? You're probably like 5 foot, 5 foot 10 inches, 10.2 inches. You're not, exactly 128 pounds. You're 138.34 pounds, that sort of thing. There's rounding involved. Technically, temperature. If outside it says it's 78 degrees right now, well, no, it's 77.91 or it's 78.1. Okay, decimals involved there. Okay, so it can have a decimal in between, but points scored in basketball or in bowling, those do not take on have decimals involved. All right. So anyway, if decimals can be involved, it's a continuous variable. Okay, so technically, there could be, millions of people between 5'10" and 5'11" because they're 5'10.1, they're 5'10.9, that sort of thing. All right, so you'll have to know the difference between discrete and continuous. That's going to be really important for us. This, not so much, what follows, so I'm going to read it quick. So variable at the nominal level, it's at the nominal level if the values of the variable name, label, if the values of the variable name, label, or they categorize. Okay, so it doesn't allow for them to be arranged in any specific rank or order. Okay, so categorize, right? Male, female, smoker, non-smoker, that sort of thing. Runner, non-runner. Variable is at the ordinal level if it has properties of the nominal level. However, the naming system allows for them to be ranged in a ranked or specified order. Okay, so economic status, low, middle, high. That's better than that. Letter grades, okay, A, B plus, C minus. This is better than that. Like, we can rank those. We can, put, if we're saying, being in 12th grade is of more importance than 9th grade, you can rank by grades, that sort of thing. All right. Variables at the, where are we at? Interval level of measurement if it has properties of the ordinal level and the differences in the values of the variable have meaning. A value of 0 doesn't mean the absence of the quantity. You can do arithmetic operations such as addition and subtraction. So temperature, okay, because I can't say like, if it's 60 degrees out and it's 30 degrees out somewhere else, it can't be like, oh, it's, the temperature is, twice as high, somewhere else. Okay, so ratio of temperature doesn't represent a meaningful result. I can say it's 30 degrees more, right? If someone got an ACT of 30 versus an ACT of 15, that doesn't mean they did twice as better, okay, but they did 15 points better, okay? So it wouldn't divide that sort of thing. All right. Anyway, so that is an interval ratio. Now, a variable is at the ratio level of measurement if it has all the values of the previous one. That's starting to be a theme here. And the ratios do in fact have meaning. So a value of 0 means you do have an absence of the quantity. Guys, a temperature of 0 doesn't mean there's no temperature out. It just means it's 0. So arithmetic operations such as multiplication and division can be performed. No one has a height of 0. No one has a height that's negative, that sort of thing. So, you know, if someone is 6 foot tall and another person, you know, a toddler is 3 foot tall, that person is double their height. Someone is 160 pounds, another person is 80, they are double their weight. If one team has 80 points, another team has 40, they have double the score. So you can divide, and it makes sense. So variables that are nominal or ordinal, the first two are categorical variables, and then variables that are the last two, interval or ratio, are quantitative. All right, folks, it's math time. So, show the distribution of a category variable as, so pie charts show the distribution of a category variable as a pie whose slices are sized by the counts of percents. For us, it's going to be percents. A pie chart must include all the categories that make up a whole. Use a pie chart only when you emphasize each category's relation to the whole. You need the whole. So you guys are going to have to write this in. I believe you have population by age in Litchfield possibly written in there. I think you do. You just got to add this in. So this is from statsamerica.org, which we will use for our big Illinois Towns project, which is pretty awesome. So according to the data in 2021, there were almost 1,400 people in Litchfield between the ages of 0 and 17, 471 between 18 and 24, almost 1,600 between 25 and 44, a little over 1,900 between 45 and 64. Crest boys, shout out to you, Pops, on this one. And then there were about 1,600 that were 65 plus. If Elver still lived in town, we'd give a shout out to him. Anyway, all right, folks, if you add up all those numbers, you get 6,960 people that were in Litchfield. So what we're going to do is we're going to take all these counts, we're going to divide them by 6960. Now I want us to round to the nearest tenth of a percentage always. So that's like 3 decimal points, essentially. I mean, 3, like, you're going to see 3 decimals on here because it's going to be like 0.201. So that's 3 decimals there. Multiplied by 100, that's how we get 20.1%. Do 4071 divided by 6960, multiplied by 100 immediately. That's how you get all those percents. Okay, so here's what I recommend. Now, I did kind of go in order. It kind of makes sense for this. All right, and what's nice, if I add 20.1 and 6.8 together, that's just over a quarter. So that's what I did. So always go right in the middle. Go right in the middle there, bring it down, and then 20.1% is a little less than a quarter. So if this is a quarter, I thought that was 20.1%. And in the next 6.8, 18 to 24, if this is a quarter of it, then this would go slightly past. It could probably be there. All right, and if I add up 20.1, 6.8, and 22.9, that is what? 49.8%, which is just under a half. So actually was slightly off there. So those 3 age categories gets me 50%. And then 27.2 and 22.9, if I add those up, that's 50.2%. So that's the other half. 27.3 is a little bit over a quarter, so a little over half of this half. And then the 65 plus 22.9 would be this. Guys, you're only going to be wrong if it's obviously wrong. You know, if 20.1 is made more than a quarter of it. Okay, that's be obviously wrong. All right, so we've got Yogi in the house too, and if anything stirs outside, he gets upset. So I would like to not lock him in the bathroom. So we'll give him another chance here. Distribution of calculus semester grades, because I've done quite well here in calculus. I guess I need to make it harder this year. So there are 202 grades we have. Just add them up, you get 202. Take 125 divided by 202. Again, I'm going to get all of these percentages. Okay, I add them all up. That's all the grades you can get. And I divide by 202. Okay, so 61.9% is more than half. That is more than half. I've got an A. All right, so if I add A's and B's together, I'm going to have 78.7? I should have a calculator nearby. And that is a little bit more than 3/4. So that's why I put I made the B's up here because 3/4 would be this right here. And then C's, D's, and F's add up to less than 1/4, like hardly any F's here, so I can draw an arrow to say 2.5%. We'll do more of these in class, all right, promise. Now, bar graphs and histograms, essentially, like, some people are going to be like, they look the same, all right? I mean, it literally says histograms resemble the bar graphs, but so something here, the horizontal axis is marked in units of measurement for the variable. Anyway, I've got more notes here on the back that you can, I do want you to write down somewhere. Stem plots, those look like histograms turn on in. They don't work well for large data sets. We'll see that in a second. And a time series plot, you guys have actually seen that if you've seen the Dow Jones marked over time. Okay. Time plot can reveal trends, cycles, or changes over time. And we'll see some of those here as well, either today or the other day. So here's what I want you to write down. So pause it if you need to be able to see. Okay, so bar graphs. So a bar graph contains discrete bars representing categorical data and facilitating the comparison of values across categories. All right, so a bar graph showcases categorical data, and it's a diagrammatic comparison of discrete variables. All right, so that was a few different definitions that I just put together. It's all about the discrete. All right, discrete and categorical. Oh, sorry about that. Gosh, we're off to a fantastic start here in video quality. Histogram contains connected bars, almost always, displaying defined intervals and corresponding frequencies or proportions, showcases distribution of numerical data, and represents the frequency distribution of continuous variables. Presents numerical data with bars that are connected and continuous. All right, so if you need to pause any of this to get this down, if you need to pause this video, get any of this down, go ahead right now. All right. We're gonna move on, just talk about a few more pages here. So I've just got examples here on the next pages. There's nothing to be written down other than look at here at the bottom, the horizontal axis. These are all categories. Denmark, Finland, these are all countries. Okay, that's categorical data right here. Okay, and then it's kind of flipped. This is all categorical data too. If people graduated from high school, got an associate's degree versus, you know, professional degree, doctorates. Okay, those are categories. Those are bar graphs. We see bars. Now we'll talk about, I see these are definitely bars, but we'll see why they're different. Cancer rates, okay, so again, got male, female, the two categories there, and then you have them broken into races. Okay, so, you know, these are bars too, but take a look here. So these are intervals, all right? This is anyone 16 to 24, and technically your age, you know, your age is not exactly 17 or 18, it's 18.3 years or something like that, but these, the horizontal axis here is in intervals. It can be anyone 35 to 44. It's not like it's one category or one race, one of the two genders we have up here. All right, bars are connected, continuous, that sort of thing. Now, we're gonna see this sort of distribution here. It can be connected and will be connected for us later. Okay, so first off, what does this look like? Do you guys know of this special curve? It's the bell curve, the normal curve. That's chapter 3. Anyway, this is numerical data down here at the bottom. Okay, we're talking about heights. Could be connected. And again, so someone is not exactly 5'10". They're anywhere between 5'10", someone is not exactly 5'11", or it could be 5'11.01 to, you know, 5'11.99. So that's technically continuous. Histogram of age of death of Australian males in 2012. Again, you've got intervals here at the bottom. It's continuous. Okay. Again, talking about age. So on 8/14/23, I am not just 35. I'm 35.03 years, right? So again, age is a continuous variable there. All right, we are getting close here. So on the back, you know, heights do follow the normal distribution. So it's a symmetric bell curve. Okay, so that can happen. There's also something called uniform. We don't talk about that a lot. When it pops up, you'll see it. Okay, so skewed to the left. It's all about where the tail is. Skewed to the left means you have a lot of data pulling this to the left here. Okay, they can maybe be outliers, low outliers. Skewed to the right means you could have some high outliers. Okay, so the tail is being pulled to. There's a tail to the right that's definitely longer than anything on the left. Here you have equal tails on the left and the right. All right, histogram is skewed to the right if the longer tail is on the right and of the mode. Okay, and a histogram is skewed left if the longer tail is on the left side of the mode. Okay, so the mode is the most frequent one. So like right there and right there. Okay, so this one is skewed right. You can see a little tail here. That one is more skewed left. This is, and then you got a little bit more of it drawing to the left too. This kind of looks symmetrical right here, right? But you got more of a tail to the left. And so this one right here, this is skewed to the what? Skewed to the right. Skewed to the right. This one right here is skewed to the, I can barely see, it didn't print well, but you got a lot going on over here. There's not, I mean, these numbers are being hit here, but there is a little bit of a tail. So this is skewed to the left. And if something is negatively skewed, i.e. skewed to the left, the mean is dragged down. Guys, if we have a lot of people doing well on an exam, but we got like 5 people getting 30s or below, the mean is going to be dragged down. The median is going to be higher than the mean if it's skewed to the left. If it's a normal distribution, the mean, median, and the mode are all the same. If it's positively skewed, you know, if you got a neighborhood, all the homes are 200,000 for the most part, but there's 5 homes that are $2 million a piece, where the average home price in the neighborhood is gonna look more expensive because it's skewed to the right. Okay, folks, we just got one more page to look at because we're gonna do this sweet histogram on Tuesday the 15th. I want you real quick to go to page 15 here for me. We're actually gonna write some things down. So in 7 through 14, so we got 2 books that we use here. One SLU recommends, and another actually a community college here up north in Illinois uses. It's pretty good one. So 2 different books we're using this year. So describe whether the underlined value is a parameter coming from a population or a stat. As a population can be small, you know, or it can be, you know, 320 million people in America, that sort of thing. So find the 2010 national midterm. 12% of the governors of the 50 United States, that's all of them. 12% of all of the governors, that's a parameter. That number is a parameter because it's talking about all the governors. 12% of them were female. The average score for a class of 28. Now, that doesn't sound like a lot, but that's the entire class. Okay, so that's the entire class. You guys could be a population. Now, we're going to use you always as a sample, but you could technically be the population. You are my 23 stats students this year. You're the only stats class at Litchfield. So this is a parameter, 72%, because it's all of them. In a national survey of 1,300 high school students, 32% reported someone had bullied them. Well, folks, there are way more than 1,300 high school students, so that is a statistics because it came from a sample. In a national survey in substance abuse, 10% of respondents aged 12 to 17. All right, so they only asked people aged 12 to 17, and they didn't get every 12 to 17-year-old in, what, America, I'm assuming? Anyway, that is definitely a statistic. Ty Cobb, folks, that was his entire career, and his career was done. So that is a parameter. That was his whole career, and his career was finished. That number is a parameter. So only 12 men have ever walked on the moon. The average age of these men at the time was just short of 40. Even though it's only 12, that's all of them. So that is a parameter. All right, hygiene, folks, 23% did not wash their hands. That is disgusting. So that is a statistic because they only interviewed just over 6,000. Okay, and there's 320 million people in America. All right, so that's a stat. And then interviews of only 100 people said 44 of them wanted the minimum age of conducted that found that 44 could state the minimum age required for office of the U.S. president. Oh, shoot. Is it 35? Man, I hope it's 35. So one of them's 25. I'm pretty sure this one's 35. 25 is a rep, I believe. Anyway, so 44%. Hopefully it was one of them. That's a sample because obviously there's way more than 100 adults in this country. All right. Is the variable qualitative or categorical, or is it quantitative? Nation of origin: Germany, America, Mexico, Canada. It's categorical. Number of siblings. You can do some math with that. Quantitative. Grams of carbs in a donut. Quantitative. Number on a football player's jersey. Yes, it is a number, but I can't, subtract number 91 minus 33, and then boom, I know I'm left with this position. So that doesn't mean finding the mean number in a football team just makes no sense. That's categorical. Number of unpopped kernels in a bag of ECT microwave popcorn. Quantitative. Assess value of a house. Those numbers we can do a lot of stats with that. Quantitative. Phone number. You can't do anything meaningful math with your phone number. That's a categorical variable. And your student ID number. That's gonna be real important when you're in college. That's also categorical. All right, and then lastly on this page, is this variable discrete, no decimals, or continuous? Goals scored in a season by a soccer player. It's discrete. 0 all the way up to 40, right? You can't score 21 and a half goals, Now you do get half of, you can get 13.5 sacks, right? So you can get a half sack. Now you can't get a quarter sack, so technically it's a whole number or just a decimal, and that is technically countable. Anyway, we're not going to talk about sacks. Volume of water lost through leaky faucet. That is continuous because, I didn't lose, 2 gallons. I lost 2.81 gallons or 1.94 gallons. Length in minutes of a country song. It didn't say minutes and technically for minutes and seconds, those are rounded as well. But it could be, 3.0 minutes. It could be 3.06 minutes. It could be 3.97 minutes, 98 minutes. That's 59 divided by 60. Anyway, that's technically continuous. All right. And number of sequoia trees in a randomly selected acre of Yosemite National Park. That's discrete. You don't have half of a tree. All right. So, folks, that is it. We have essentially done all the definitions. Here on out, we will be doing some sweet math, and starts out really easy, as I told you on Friday, and then it just gets more interesting. And stats is great. It's a great course. We've got some new data. It's gonna be sweet. It's gonna be a good year. All right, that is definitely long enough. This is Yak Math Videos signing out.